Uh, yeah. So anything else about the logistics? So Venkat, you should have it in around 10 days. Uh, I sent it yesterday or day before yesterday. Yeah.
Yeah, yeah, I saw your message. Thanks.
Yeah. And yeah, so I have sent the plastic plate too, and but you will have to buy the struts. So I haven't sent the struts.
I have
Uh,
yeah, standoffs. You mean, right?
yeah. So the standoffs. I
I
have a
have.
box of it. Yeah. Yeah.
I also have a similar box. Right.
And yeah, so the plastic plate I have printed, I have sent it that. And for Venkat, I have sent two extra V 1.1 PCBs. So if you want to play with Galaxy with that, so you can use that at some point whenever you and Red want to play with those.
All right. Yeah, sounds good.
Yeah, AliExpress calls it standoff as well. So how long do I want them to be?
So I don't know. It could be this. I have like maybe half a centimeter, or sorry, 5 millimeters. So it has various sizes. So I used like M2.5 into 5.
Exactly. So that's why I asked
Yeah.
which size do I need? How long?
You can take like 5 millimeter one.
Is
Yeah, the 5 millimeter one
longer
should work.
is longer
But
bad or not bad?
so if it's too long, then it will hit the plastic layer, the middle one. There is a middle layer, right?
Yeah.
I think there is the battery goes there, so it will start hitting there. So I've used 5 millimeter, and there is still some clearance left.
Yeah, you can
Okay.
just look at the length of the standard tumbler board standoffs. Those are about like half an inch, I think. So you might even be able to
Yeah. So
reuse them. If you take it off, you might be able to reuse it.
yeah. So basically, I'm using the same standoffs for the PCB which came, and then for the RPI hat, I'm using the small ones. So if you see,
Yeah.
uh, these ones are the same which came with Tumblr, but these ones, the small ones on which the RPI hat is standing on, it's the small ones, 5 centimeter ones, I think.
Okay. Well, I found a kit that has lots of 45 pieces. I don't know for $15. 300 pieces for $15.
Yeah, but maybe like this Amazon
Oh,
one because it had different sizes. So
Do you have an update on the code? It was compiling last week.
no, I didn't have time
oh,
to. But
Ah,
I think Cloud, what Anthropic released this Cloud Codex or something, the web version of it. So this code is actually written by GPT-5, and then I'm using Cloud 5 to review it. So it gave a lot of comments. So
is it okay if they're made out of nylon instead of out of brass or steel or whatever?
yeah, it doesn't matter as long as it's not touching the metallic part. Okay, let's start with the Cryptobotics white paper now, and I have been working on. It's mostly NAS work right now. We can review it. So it's basically like a white paper kind of. So initially, I was thinking of having a list of protocols that we will be using on the CryptoBot, but then like Venkat had a idea of having it a larger. I don't know what to call it, but like a macro, meso, and micro scale uh, kind of paper, and then expanded on it a lot. So we can review that uh, text right now, and then if you guys have any comments, then you can put the comments in GitHub link. Um,
Yeah, just comment on the files because I think there is a file called cryptobotics.md which I think you can skip entirely. It's mostly the content of the third file, whitepaper.md. These files are completely like generated by AI. It's just prompting. So the it's you don't need to view it with any sort of uh, formality or something. It's just a scaffolding to push the conversation forward and see what's wrong, what should be added, what shouldn't be added, and the details will be filling in once we have the scaffolding right. So start with protocol reference .mark.md. I think it's faster to read regarding what's needed here.
Yeah, I was not sure about these lab.
Yeah, these are by process. These are generated by processing the entire conversation thread in Discord.
Okay.
That's what is generating this extra stuff. I think somewhere someone posted it.
So this is just the summary of the rest of the all the protocols, right?
Yeah, this is the list of protocol you mentioned because someone has to search
Yeah,
through it. That like the problem with like this thing, all these protocols is like I still like okay, we have these protocols, but determining the meaning of these protocols is another thing. Like I'm a user, but so I need to search, but I don't know what to search. So maybe I have a keyword in mind, and I come in like I search it in this markdown, and we can get something possibly. I think that will be the main use of a list of a protocol. Like if you list only the names of the protocols, you won't have the search terms. You don't know what to search.
we could add the multisig, some multisig protocol or this voting protocols or some sort of kill switch. Yeah, so two things could be added: kill switch protocols and multisig for like voting protocols.
I'm I'm missing a little bit of context, I think.
Right.
Some might
That's
be
where
list.
the white paper
Yeah.
markdown should come.
So if
You
I
also,
understand correctly, the intent is anybody who wants to participate in crypto robotics, they can come to this paper and get like a inventory of existing protocols that they can use, as that's one of the primary values here, right? And then build up to
Yeah. Yeah. So the initial idea was just like I would list. Then you had some note on, I think, what Substack. Then I started realizing that like there is no cohesive uh, uh, place where everything just like is ties it, where something the cohesive idea is tied down to all the small protocols. So there is like nothing meso. So then I thought, okay, should we write something related to that? So this is just an open idea right now. So right now we have the list of protocols that keeps on expanding. But yeah, so then we could write something, text relating all those, and then provide some reference with Tumblr. So that was the initial idea.
okay. Yeah, I remember mentioning the micro, macro, meso framework because I've been thinking about that, but I don't remember the specific note you're referring to. But yeah, I think the kind of thing I'm thinking of for effective mesoscale stuff is if you look at the DWeb community. So the DWeb community is distributed web, and they have an annual conference and other things. But it's built on top of like the IPFS stack and like all the technologies you can use to make decentralized websites. But what they do is add a second order kind of like narrative around it. Like, why should you care? How does a distributed website work? What are the things you should care about? What's the web culture that it might foster? So that's what I think of as a meso discourse. So one way to maybe think about that is if this whole effort is successful, and a couple of years from now, there's like a crypto robotics conference or something, maybe 100 people show up with their projects and want to talk. What are they going to talk about? Whatever the agenda of that little conference is would be, I would say, the meso stuff. So one way to maybe get there is just imagine such a conference and speculate about the agenda, like what talks would you like to see, what case studies, things like that. And macro is something like IoT is a macro level narrative, like Internet of Things. It's like fairly clear. We've been talking about it for 10 years. People understand what it means. There are examples. So IoT, I would say, is a mature macro level discussion.
That way, like CryptoBot, it's kind of appearing, but like, so if people have like some sort of idea about what it's supposed to do, but yeah, there is nothing like people refer to it as such. So people know that there is some sort of crypto and robotics thing is coming. So people write articles about it, and the SUI people are actually doing something related or doing some random experiments. But yeah.
Yeah. I think at the moment you're probably the one who's gone deepest into actually doing something. That Sia, no, not is it Sia? Yeah, the Sia.
Sui.
Sui. Oh, it's not Sia. I thought Sia was
No.
the scientist. Okay, that's a different.
Yeah, yeah. I don't know how why it's called Sui, but it's Sui.
Yeah, that didn't seem particularly deep. So I think a superficial example of crypto robotics, an equivalent would be you remember the SECAN Google command project, and we were all initially impressed because it was using natural language to command the robot to do things. But you think twice and you realize it's very shallow. They're just using LLM as like a supervision layer. The AI has not gone deep into the robot operations itself. So I think something similar holds for the crypto robotics end, right? Controlling over forecaster, it's level 1 depth. Level 2 might be maybe it has an onboard wallet and can take orders for money. But I think it gets really interesting once you start asking, like, for example, can you do crypto scavenging where you can pick up a part from another robot, but you are only allowed to use it, like, you find a broken arm from somewhere and you've lost an arm. So you pick it up and attach it to your body. Can you actually use it? You can imagine a crypto layer on that. Actually, a good example of that is in the Ukraine-Russia war, right? The John Deere tractors being used in Ukrainian wheat fields, they have a lot of like encryption preventing farmers from hacking them, basically. But I believe the Ukrainian soldiers basically hacked into them and turned them into war vehicles, something like that. So that's the sort of thing I mean, where the crypto is used non-trivially in the deep architecture of the thing, including like, can you use spare parts from one to repair another? Things like that, especially in like conflict zones.
So you would think like they're like this macro, meso, and micro direction, but there's also the depth of the actual technology we're talking about.
Oh, I mean, what I gave you is an example of a macro narrative, right? This is one direction crypto robotics could go, where the crypto character is not at the level of the robot, but at the level of the smallest possible components that could go into a robot. Like you can imagine every motor and every sensor has like an encrypted interface so that only with the right permission structure you can attach it to a robot body and use it, right? So what is the grain level? So if you do crypto robotics this way, you create like an extremely rich modular scavenging environment. You create basically interchangeable parts type culture, but with fine grained permission controls, right? So that's one possible macro storyline of what crypto robotics could be. Another could be like, like Asimov's three laws are kind of crypto robotics if you think about it. Like if a robot can enforce hard rules, like I will not hurt a human being, or there's stack between first law, second law, and third law, that sounds like a smart contract to me. Like it's not loosey goosey like LLMs or RL where it may or may not happen. Those are hard boundaries, and if they come into conflict, the robot will go into stasis or something. So that's a
Yeah.
different narrative, right? This is at the level of a single integrated robot, not at the level of like parts. So that's a different macro narrative.
Wait, can we
Maybe
uh,
go on,
uh,
Mir.
yeah, I wanted you to slow down. You just said a lot of different things. If we could unpack them, but starting with this idea of private crypto for the smallest, let's call it reusable component. And can you say a little bit more about, where it fits and so on? Where's the wallet? The ARM itself has a wallet.
Uh,
I mean,
a wallet is a very specific, like blockchain crypto piece of technology. I'm using the term crypto much more loosely, right? Like take Apple connectors. Like sometimes you connect, non-brand name accessory, and Apple iOS will complain that this is not a standard supported accessory or something, even though it otherwise is like the right connector. I would consider that part of crypto robotics, because probably they have like some very simple signing or RFID or some crap that enforces a permission, right? So,
yeah.
so I would call that using like an atomic composable crypto pattern in building your robot. Wallets are another atomic composable component that may be useful at certain levels of abstraction. I don't see the point in every motor and sensor having a wallet, but maybe every SBC or every sufficiently powerful
Okay.
compute
I,
module should have a wallet.
so let me stop you for a second. We spoken in the past about robotic reliability. We were talking more about software parts, that each piece of software is signed so that when the robot wakes up, it can know if it was compromised. So what you're saying is when the robot wakes up, it can check the, let's call it signature
Yeah.
on each component and say, yeah, some of these components are not authorized.
Yeah.
So I understand, I agree, it's important, but it sounds like it could be more exciting. What I mean is, you just said, oh, instead of RFID, we have crypto. But it seems, to me like we're using only teeny bit of crypto. All we're doing is getting, digital signatures on RFIDs. But crypto is more than that. I'm
So
just
this is
wondering,
why the three levels framework
can we
is
talk more? Can we go deeper into
okay.
how crypto
Yeah.
can be used for something specifically robotic?
Uh, uh, Maybe like to give you some context about this macro, meso, and micro stack. So basically, like I don't know the person, but somebody introduced it in the protocol school. This layer of protocol stack, like you have the grand global narrative scale at macro, and then something in between in meso, and the micro is basically the one you are talking about. That's why like we have organized it this way. If this is the best way to do it, I don't know, but yeah, right now this is what we have.
Yeah, this is by Giovanni, who was one of our faculty in the summer program. So he's
Hmm.
teaching a course on this thing called cyber physical systems. So this is his framework for talking. So he likes to use the example of There's the Roomba level of robotics. So he's mainly interested in urban infrastructure robotics. So there's the
Hmm.
Roomba level, then there is like, the sidewalk level where maybe multiple Roomba scale robots are interacting. And then the city infrastructure level where maybe there's like, a code passed by the mayor of the city saying that Roombas have to follow certain rules, right? So that would be one example of micro, meso, macro. But to your point, I think the key is, I think, to start at the micro level. Maybe start with something like, what happens if you use a very simple rule that every connector is identifiable and has like a permission condition, like whether or not it can connect to any other component. So that's the micro level assumption. Then you work through the implications. Now what happens at the meso level? Meso level, it might be something like, my friend robots can scavenge me if I'm broken, but my enemy robots cannot, right? That can be one meso level implication, which I think is actually very interesting. It changes the dynamics of what happens there. And the macro level stuff might
How can you
be,
do that?
what is the whole language of permissions that govern the component universe, right?
Just a second. How can you do that? How can you make it so if a Russian robot finds a Ukrainian arm, it can't use it?
So
We
that's
were
where I would
talking
go to
about
this
the
white
opposite.
paper and look. I would look at this white paper and say, is there an existing protocol or technology that can actually guarantee that? Like maybe something with ZK proofs or something that says that if a non-friendly actor tries to use this component, it blows a fuse and kills itself, right? Self-destruct mechanism. So this is
But
where you would,
isn't Apple already doing something like that with their cables already? So they have some chip and the USB endpoint, which basically does some sort of authentication. That basically tells you if it's a real Apple product or not.
Now that I look at it, I think another thing that is missing, right, is like a general context map for the things that robots, the kind of robots and the kind of task that we are dealing with. Currently, there's also the I think the robotics like in general is like too large to fathom for some readers, or in some cases we were talking about Mars rovers on Mars, and that would be robotics, but a very particular kind of robotics. Would it be useful here to like define the kind of range of tasks, or is it kind of anti-productive to do that here?
Well, a lot of people would consider like factory automation, robotics.
Yeah.
To some extent, it is like, for example, the Amazon uh, sorting robots are a more robot than the pick and place automation.
Hmm.
And basically, there could be some sort of let's say a work. So one narrative would be like the work done by the robot, but how would you ensure that it's like provable, or how would you prove it that some work was done? So that is like one narrative I was thinking about.
Yeah, so if I am to put myself in a reader and read this, I think I will like disambiguate, like I'll distance myself, because the robotic this current version talks about is a different kind of robotic I am thinking about as perhaps as a factory automation worker. So I think I should add something like the context we're working with, perhaps in the next version.
Mm. Maybe we can start with the micro parts, like what are the micro things we can do, and then try to build a meso part on top of it, right?
so I don't know if this is a good way to write a white paper about the general concept of crypto robotics, but it's probably a useful exercise to work through our own
Hmm.
robot from micro to macro level. So start with the Yakusar and say, under the two macro narratives, how would you sort of like tear it down and rebuild it, right? So our tumbler-based Yakusar, if you completely break it down into its components, how would you redesign it in crypto robotic ways under like one or two pathways, for example, right? So it's worth like working through a specific case.
Cool. I guess first this is still too long. Like if we start if we start the next version, I guess yeah, like the path from micro to macro will be like more readable than macro to micro on a case base and on a case base study of what would happen in Cryptobotics.
The robonomics paper, it's kind of okayish, right? But they have like I think abandoned the idea at all completely.
They
Wait,
they
what's
they turn
ergonomics?
to some they turn to prototizing some things.
Yeah, so basically it's this paper. So they were trying to do some crypto and robotics 8 9 years ago with Ethereum. They did some experiments. It's basically called robonomics, economy of robots. So they had some initial ideas and they were doing it with some Polkadot or some other tokens and
Okay.
some but I think this they have abandoned it completely and now they are doing some IoT stuff. I don't know what, but like some of the ideas in that organizing it is good, but it's like all the stuff is pre-merge, so a lot of the stuff that has happened in the last 5 years, it's not there.
Yeah, I would not take cues from that. And especially, I would say starting with the economics aspect is probably a mistake because it's not the most foundational one. Like the economic aspect is worth enabling and activating if more foundational layers are better done. Like, IPFS for data storage for distributed robotics, that feels more foundational to me than the economic layer. Actually, this might be a useful thing to try and like do, which is what is this sort of like almost Maslow hierarchy type diagram for a crypto robot? What is the bottom layer of the pyramid? What's the second layer? What's the top layer? So crypto economic enablement, I would say, is the top of the pyramid. Bottom layer might be something as simple as basic reliability under various conditions. Like I was just looking at the funny shit that happened during the AWS outage. There's a company that sells smart mattresses, and when AWS went
Mhm.
down, the mattresses started heating up and stayed hot because somebody clearly very thoughtlessly designed a temperature regulation loop that for some reason phones the cloud to keep the mattress at a regulated temperature. Now, this is dumb, right? And I think this is within the scope of crypto robotics to say a good design pattern would have autonomy of basic functions at the completely local level so that even if the power is lost, connectivity is lost, it won't do stupid and dangerous things like overheating, right? So that feels like it should be within the scope of crypto robotics philosophy. Like, what should be autonomy at the local level that's retained and governed by the individual robot versus what is safe to give to the cloud.
And I want to ask a question. Why should there be a cloud? Let me explain. If we have crypto robots, I'd expect, as we once tried to do, each robot will be a node in the distributed ledger. And of course, we have problems because robots are moving around and we don't have so many of them and so on. So there's an aspect to crypto robotics. How do robots do crypto without having a cloud?
Yeah,
Cloud's not
and
part
this
of
is
the
why I
robot.
think
Yeah.
a pyramid would be a good scaffolding for this. So maybe up to level 3, it can function entirely without cloud support. And maybe cloud support is a very high level layer where if you want really powerful compute to do some deep machine learning stuff, then maybe you use the cloud, but it's not necessary for basic operations, right? So, but I wouldn't necessarily just preclude using the cloud. I would just put very strong guardrails around it.
Now, it's even counterintuitive when we talk about autonomy, right? Because if we talk only about the example of the mattress, okay, if we see the mattress as a robot, I mean, no cloud just doesn't work anymore. There is no autonomy at all, right?
Well, it should have been designed. So I read a tweet where somebody's bed was stuck at a particular angle and it wouldn't go down.
But it's the problem we have that I see in many robotics companies. You know, over the past few years, we have met a few hundred, okay, and that so of course the robots in we talked about earlier that go in industry, you know, on the manufacturing, okay. We're not talking about those. We're talking about robots that are supposed to be autonomous. So, for example, let's take just the Roomba. Okay, the Roomba can work without being connected to the internet, I believe. Okay, I'm not completely sure about that actually. I will do some tests. Okay, but it's supposed to be able to work without being connected to the internet, right? Otherwise, it's not autonomous. Okay, and we don't even need to break down into energy autonomy and behavior autonomy and such kind of topics. Okay, that I agree with what Venkatesh just described. Is that it looks like the first few layers at the bottom of this Maslow-like pyramid should really be independent of the cloud, of internet, even. Otherwise, we're not talking about autonomous robots. Okay, so that maybe there are two categories as well. By the way.
Hmm.
I wonder whether the lowest pyramid shouldn't be something about like a basic survival, basically.
So kill switch protocols would be at the bottom. Authentication would be at the bottom, right? What else?
Yeah, but how's that a need of the robot? The need of the robot is to know that it actually exists. The need of the robot is to be sure that all of its arms belong to it. Authentication is a functionally on the lower level. Can somebody put up some Maslow pyramid so we have it in?
Sorry, Mayor, but it depends. If we see authentication as an immune system, okay, it's pretty low level, no?
I'm willing to hear about immune system, but authentication is a function.
So identity can also be considered a function, right? So for example, yeah,
Yeah.
this is just like a scaffolding. I wouldn't attempt to like precisely map something like this. Actually, something like the OSI network stack diagram might be a better reference point than the Maslow hierarchy, right? Because the OSI stack or TCP/IP stack, they don't have like autonomy and agency and identity, but they have like a similar kind of like technical level. If you can find a good diagram.
So, Venkatesh, it's interesting you mentioned the OSI stack because I was thinking about that when at the beginning when we are looking at the white paper documents, and I was wondering whether that was enough. Looking at the technology matrix that we reviewed a little bit earlier, I wonder whether it can be a starting point, but I wonder whether it's actually not a graph that we need here.
But this OSI is like a more protocolized layer, similar to for the Maslow hierarchy, right? It's
Mhm.
Maslow hierarchy is more hazy, but OSI model is just more protocolized version of it,
Yeah,
kind
this
of.
is more flows and stocks
Yeah.
than stocks, and it's harder edged. But if you go back to the Maslow one, you can kind of translate this to robotic terms. So if you wanted to say that, like imagine a situation like you've seen, I think in Iron Man 3, all the parts of the suit are independent and they kind of fly around and they assemble
Mhm.
into the overall suit, right? At what point, when the gloves and the boots and the shield and all that, when it's coming together, at what point of the emergence does the suit acquire an identity and is able to be like a proper exoskeleton, right? Because at some level it has to impedance match the human occupying it, so Tony Stark. But when it's just two gloves flying at its hands, and maybe he's at the 10% stage where he's wearing the gloves, but the rest of the suit is not complete, I would say at that point, those are more like smart prosthetics. They're not smart enough to actually be a robotic exoskeleton for him. But by the time you
Mhm.
get to 80% completion, you could say that the robot has its own identity. So that might live at a level 3 version of this. So this might be something like uh, emergent identity or something. I don't know. We can sort of brainstorm this offline. But the way I'm thinking about it is like at some level, the robot or the Iron Man suit has an identity, right? Because he does things like he gets out of it and walks off and does stuff and tells the suit be on sentry mode. So that's something you say to like a coherent agent, to like, do certain behavior, stop people from entering the space. But you can't tell that to just a glove. You can't tell a glove be in sentry mode. Maybe you can, but there's like a certain level of emergence where Mayer's question of what does the robot want is not being addressed. Well, there's a level below which the robot as an intentional entity has not even emerged. So I would put that somewhere in the middle, maybe.
Mhm.
Yeah,
Right.
so actually, when we put these two graphs side by side, one is like the need side of the need of the robot, and then one would be more like the way to address those needs,
Mm-hmm.
and to make the connection between what need is being addressed by what ways would be like would kind of be like a major definition point of what the micro level would be, like just figuring out the connection between the like the physiological needs, and we'll connect this with the say the lowest OSR level, or two levels from the OSI levels. That would be like a major definition point.
Yeah. Perhaps there is a third graph that will be needed to be in the mix. It's the three laws of robotics or something. Perhaps that comes out from a Venkatesh competition that started last week. Okay, so the reason I say that is because Maslow's pyramid is really for human beings, and I don't know well enough to comment on that, but I wonder whether it's about the modern human being. Okay, I wonder about that. Okay, but the thing is that the for robots we have to remember that robot means slave. Okay, and so this pyramid doesn't apply directly. We don't want it to apply directly. Apparently, when I say we don't want, is that it seems that we implicitly see robots as what the word means, basically. Implicitly.
Well, it used to mean maybe 100 years ago, but I don't think it means like a slave anymore, right?
I,
Wait. Look at robots now are
so,
counted like
so,
they will replace the people at work and stuff like that, or be your housemaid. Okay, isn't that some form of slavery?
Yeah, like contract workers, maybe.
no, I,
You want it to obey to each of your order. Okay, no discussion. Okay.
Yeah, so rather
However,
than the
we don't want the robot to obey an order like go kill my neighbor, right? Okay. And so because of that, we have a restricted autonomy. Okay, it's a tool. It's
Yeah,
not an
but for
a
example, the
fully
self-driving cars have to do moral calculations, right?
Yeah,
no,
but
but
they are still a
what they
slave.
are. We decide what they are. Anuraj, you know that under intellectual property laws, robots can't invent by law, not reality. Robots can't own their creations. So I'm agreeing with Eric. So let's flip the question, if you don't mind. Robots want to be free, okay? And the question would be, how does crypto interact with robot freedom? For example, a robot could use crypto to know that it's making its own decisions and not because Anuraj decided it has to follow Asimov's 3 laws. And as an example.
Like maybe it's more like it's not like there is a robot's need. There is more like humans need for robots. It's the humans that need things, and part of it might relate to robots surviving, and but part of it might not be related to robots surviving a particular condition. So the central point would rather be like the Maslow point of this is that it relates to the human's need for robots to do something instead of the robot's need itself, because robots don't have needs. Like robot obeys humans' need and serve humans.
But they do have needs, like for example, electricity. They need to charge, and whatever we tell them, whatever order we tell them, you know
No,
that
robots don't need electricity. We need robots to have electricity.
Right.
That's
Okay.
You're denying the humanity.
So this is actually a hot topic that I see discussed often, and it mostly comes up in discussions of how American robot philosophy is different from Japanese and how that's different from the emerging Chinese philosophy. So Americans are kind of a little bit scared of robots and try to make them behave as much like appliances as possible, where they'd have no, identity or the kinds of like personality Mayor is talking about. Japanese robotics, people say that it's kind of animistic, kind of like Japanese religion, right? And everything from washing machines to Roombas and other things, even if they look like appliances, it's given like animistic existence. And I think Chinese robotics is entering a whole different era where I really think of the standard Chinese unit of abstraction as the swarm. Like when I think Chinese robotics, I think the big drone displays and I don't know, not one robot doing things, but like 100 quadruped robots marching in formation and doing stuff. So I think Chinese robotics is going to have that character. So I don't think this is uh, a thing to take an opinionated stance on. I would say this is in the menu of narrative options for the macro level. Like, do you think robotic identity exists or not, or is it purely an instrumental tool like industrial age technology? That's one axis. And the other axis is if you think it can or should have identity elements, what level of abstraction should or could it exist? Should every motor have an identity? Should anthropomorphic entities like dog or bipeds have the identity? Should the identity exist at the swarm level like bees, right? So lots of possibilities here. The design space for macro is big.
Do you have any
Oh,
write-up or papers that talks about these different human-imposed robotic cultures?
I don't think people have written about this for robots specifically, but a lot of people have written things like this about AI, right? If you remember Marvin Minsky's old Society of Mind,
Yeah.
that was basically the agency is at the smallest micro level possible, and everything else emerges from that. That was that extreme of the spectrum. Whereas McCarthy's AI was much more, I would say, anthropomorphic level monolith. So people have done this thinking for AI, but I haven't seen it done for robotics yet.
Because that's very interesting what you're saying. I mean, my washing machine definitely knows how to eat my clothes. Sometimes it spits them out all chewed up.
Yeah.
So
I think you can actually separate out the philosophy part of the problem. I mean, it's interesting, but it's not what we're into here. But you can sort of like fence that off and you can actually engineer this. Like, if you see that behavior in washing machines eating your clothes, that's actually a decision point. Do you want to then design some autonomy into the washing machine where it can recognize phenomena like clothes being chewed up and somehow behave in response, right? It sees that it chewed up a sock. Should it then say, all right, next time I should run at a slower speed or something like that? Like, does it learn and adjust? Or on the other hand, is that something that's just happening? And to the extent it has a computational identity, it's not even aware of it. It's like, all right, that's beyond my sensory capacity.
it seems to me like we need to choose a reference robot, be it a Roomba or a washing machine or Amazon, warehouse robot, so that we can pin down some of this discussion. Even talking about charging, Roomba obviously needs charging. Okay, but other robots, suicide, the Ukrainian suicide drone, that doesn't need recharging. Need for itself. So maybe we
There's
can.
here's an interesting example for you to think about. So I have the Nespresso Virtua machine, one of the more recent models. There's a second one I've owned, and the previous model, it recommended that every 6 months you should do a descaling cycle. So they give you some like liquid you
Mhm.
pour through the coffee machine and it descales, but it didn't enforce that. So you could say that it left it to my agency as like how sloppy or careless I want to be and how much I want to let the machine get out of maintenance. It didn't enforce anything. It just suggested it. The new model machine, when it gets time, I don't know how it measures it, whether it's just a clock time or number of coffee cups you've made or whatever it, however it measures. But at some point, after you make a coffee, the light LED indicators on the machine will start flashing red and green together.
Mhm.
That's your indicator that you need to run the descaling process. But the interesting thing is, it actually retains autonomy on this decision. If you don't do descaling within the next 6 or 7 cups of coffee, it'll actually stop working. So it forces you to like enter the descaling mode. To me, this sounds like a design pattern where I don't have to worry about the philosophy problem of like, is there like a, conscious entity in the coffee machine? For practical purposes, it's acting like it has opinions and it's not letting me decide when it needs a cleaning. It is forcing me to, act according to its idea of
Yeah.
when it needs a cleaning, right? So I think to your earlier point, I think yeah, you need to have a reference robot. In fact, I think you need more than one. It would be good to have like a basket of robots as a reference benchmark set. So one can be a Roomba, one can be a coffee machine, one can be a humanoid. So maybe a dozen robot types against which to test our narratives of what crypto robotics should be.
On the micro scale, one thing we could do is like try to split the protocols listed or like we have listed until now into this layered structure. That would might give some better picture for us.
Yeah, I think that would definitely be very interesting. So I think it'll be iterative. If you kind of like sort and classify the big list of protocols into the natural clusters, then we can try to think up which one is higher or lower abstraction level. So we arrange the clusters and then we stare at it and say, all right, what's the good label for this cluster? So I would recommend doing that bottom up. Start by clustering the big list of protocols and clustering and then creating like a stack hierarchy of the clusters.
Yeah, I do agree. That's perhaps what I wanted to mean by a graph earlier. Okay, clustering is sounds great. Just one thing that when thinking about the OSI, perhaps a big difference with OSI is that OSI we see a stack here, which
Mhm.
is in practice not perfect. Okay, as you may know, this is just descriptive. Okay, the implementations are different. Okay. But there is also something is that OSI, is about everything is about encapsulation. Okay, meaning that at the bottom you have you have a packet of information. Okay, it's a piece of data, and this piece of data you put headers. Each layer will have a header or maybe some prefix or some suffix, and at the end of at the top, you end up with a big string. Okay, that encapsulate in the middle the data that you send uh, on the um, on the network. Okay, so I'm oversimplifying here. Okay, my point is about encapsulation here. Okay, and I wonder how that translates, on the galaxy of protocols we are talking about here, like A to A and what were the ones? Okay, so there are many protocols right in the matrix. Okay, but the thing that they most of them they are created and they are independent of each other, right? Okay, so for me, I don't know them enough to see whether there is any way to encapsulate them. Okay, if we can't, I don't know whether we have to, but if we can't have such kind of relationship, that would be very expensive to use all together. Okay? expensive
Well,
in
our
many ways.
last year's experiments kind of integrated, right? So we used different protocols at different layers. But overall, the use of each single protocol was easy, but it was just the combination that made it unique, right? Last year, what we
Hmm.
had.
Yeah.
So we had like all the entire stack of protocols. But if you look at them individually, like it was nothing new. It was just the combination that made it unique.
Oh, by the way, is Tailscale in the current list? I haven't scanned it fully.
Maybe yeah. We have written it as VPN. I think I don't know, but yeah, we could add that.
Yeah, because that was the one. Well, we tried to use that, but then it ended up
Yeah.
being something else, right?
Yeah, basically I had some problems with the Wi-Fi there, so and then yeah, some other
We did
issues. So I dis
ngrok, was it?
yeah. So ngrok and yeah, and what else? VPN, uh,
So
WireGuard.
yeah, zero tier was another one that we looked at but didn't experiment with. I think Open VPN. Yeah. So
And then what was this? The mesh protocols, right? So there are a list of mesh protocols. The one that works on ESP32 with Wi-Fi is called ESP32 mesh. But there are a few mesh protocols that work over these IoT protocols and 4G networks.
so
So we could list those two.
networks is actually an interesting one because my first instinct is to say they probably belong on the stack hierarchy somewhere in the middle as the network layer, but that's not actually true, right? There are extremely local, like centimeters to feet level network protocols, which would be used at fairly low levels of like keeping the robots integrity going, like all the ESPs talking together. And that's very different from the network protocol it would be in if it was talking to like the cell phone network, right? So that would be more. So this would be a difference. Like in the human body, there is the proprioception network by which we are aware of the different limbs and so forth. That's a signaling network. But then there's the other network, which is us talking using audio voices. That's like communicating between people. Both are communication networks, but one is, I would say, very low level on the human body stack, and the other is fairly high level.
A lot of the local network protocols you're talking about, they are used in home automation a lot. So MQTT thread, and there's something called Matters now. So there are these local home automation protocols coming up, which are used over Wi-Fi and thread protocols.
Bluetooth would be even
Yeah.
tighter than that, right? Bluetooth would be what, a 15-foot radius, which I would say is like maybe a swarm of 3, 4 close by robots, but that's it. Or one large robot.
How do we tie this to the meso? Like, I still don't have an idea about what meso would be about. Connect or validate.
No, I thought we started with that.
No, we started with the like a macro narratives, and then we discussed the micro. But like, what is the meso part?
I thought Miso was exactly that a robot is made out of parts, and the parts have to trust each other. You have an arm and a leg, and the arm has to trust that the leg won't dump all of the electric power regeneration on it.
So
Or whatever.
I would say the meso level is probably the level of like schools of actual implementation. So, for example, if you build crypto robots in the Farcaster ecosystem, you're probably going to have like a particular opinionated set of defaults on how to like flesh out the abstract stack diagram. And you might say, like, my human interaction loop is going to run on Farcaster. My token scheme is going to be on an Ethereum backbone, things like that. So if you do the commitment bindings at the level of a tribe or a particular school of thought, that gets you a meso level. And you can imagine, like, a conference. That's why I like the conference as like a test
Mhm.
situation. You can imagine um, Ethereum plus Farcaster based crypto robot builders arguing with people who built crypto robots on, say, the Bitcoin stack or the Solana stack, or people who are like ignoring blockchains altogether and doing crypto robots using DWeb and IPFS only, right? So that would be a meso level conference discussions. But they might all share the macro level beliefs that there should be fine grained permissions and yeah.
Would home automation be meso or macro?
I mean, home
For example,
automation is a domain. It will have micro, meso, and macro narratives, right? So, for example,
sure,
if you want to talk about home automation uh, culture in North America versus Japan and how different schools of architecture are following their ideas, that's macro. If you go to the level of should my home automation be based on RPI and open source hardware stack versus should I just buy Amazon's home automation offering wholesale, that would be a meso level conversation, maybe within the American macro narrative. And the micro level narrative would be very specific decisions like, all right, which devices do I want on the home automation versus which do I want to keep air capped, and where do I want, like, dumb devices that are not connected to the thing at all. So those would be a series of micro level decisions you might make.
Can I suggest a slightly different take here? The idea of crypto has to do with different things. One is trust, but in particular, trust between somewhat distributed architectures. Okay, so we don't have a centralized authority, so we have to have a way of generating trust on a mechanical level. And if we take the example of home automation, imagine that I have two robots in my house. One of them is a Roomba, and it cleans the floor. And one of them is called Flower, and it arranges flowers so that my house looks nice. Now, you can imagine the Roomba getting upset if every time it cleans up, immediately the flower goes around putting flowers and dropping dead leaves and stuff. So both of them are part of my home automation, but each one has different preferences. And I'm not talking now about the coordination between them, but about how they trust that each one is following the coordination in a way that they can both get what they want. Okay, when you have multiple robots or robot components that are working together to a common goal, they have a problem that they can step on each other's toes. And even if they promise not to do it, you need to have some mechanism where they know that they did it and maybe get punished and so on. And it's a distributed decision and distributed accounting, which sounds to me like exactly the kind of thing that you want to do with crypto. So if I'm looking for some crypto natural issue in robotics, I think that could be one. Let's call it society.
Yeah, this is something like dealing with network congestions. Like it is a similar problem, but in network it's like more a defined limited set of problems. But in robotics, it is more general in the sense that robots can have various kinds of intentions. So it will be a harder problem than like network congestion problems.
But
So-
it's slower. Okay, networks move very quickly, robots don't.
Yeah, perhaps that is the good thing here. Maybe.
So one element I think that can be part of this whole structure, going from what Mayor said, is there is a lot of conflict. If you start with the premise that the key point of crypto robotics is that it starts out distributed, which means there's multiple nodes, which means there is going to be conflict. So a philosophy of conflict in robotic systems kind of needs to be in the whole paper in a sense. And you can like
Say that sentence
imagine.
again. I didn't hear it.
Hmm?
You said philosophy, conflict, and robotics, and then I didn't hear what you said. It sounded important.
I said the paper probably needs some position on a philosophy of conflict in robot systems, right? And what this got me thinking about is, have you guys heard of rogue neuron theory? So
No.
this
Nope.
is the idea that the brain actually evolves. So many people used to believe that the brain evolved in a pretty top-down waterfall architecture way. Like, you start with an egg cell and it goes through the process of ontogeny as the baby develops, and then the brain eventually has like a speech area, motor control area, memory. It's almost like, assembling a computer. Turns out this view is like basically completely wrong, and the brain and its set of neurons is more like a Hobbesian conflict zone, and clusters of neurons form basically armies that are constantly competing with each other. So for example, if you don't like do much exercise, so the motor control areas of your brain are being underutilized, neighboring areas will actually try to just capture those neurons and use them for their own function. So this is roughly the rogue neuron theory, or I think it's also called the wild neuron theory. I'll see if I can find a good reference. So this is one example of what I mean by philosophy of conflict, which is the robotic system has conflict down at the smallest component level, which would be neurons, which could be something like in a home automation situation, for example. Lots of robots and appliances are running around, but they're constantly watching each other to see who's doing more or less work. And at some point, the vacuum cleaner might decide that the lawnmower is not being used very often or is not doing much work. So it's just going to steal its wheel,
Power.
right? So that's,
Power. Let's
yeah,
be
something like that. So that's
this
one extreme of philosophy of conflict. At the other extreme would be this is a completely managed command economy like a communist country, and all conflict basically goes to the top, and it's at the level of like, the home automation Politburo decides to resolve conflict. So if the refrigerator and vacuum cleaner argue about power, they both escalate the issue up to the homeowner, and the homeowner says, yes, refrigerator has priority over vacuum cleaner, right?
That does sound more like the US today than a communist country, Every decision goes to the Supreme Court, apparently, recently. Okay.
Yes.
But what about, it's interesting also the terminology you're using, because that sounds very, very military, okay?
Yeah.
Competition and the deciding decision. I wonder also whether an alternative, just to illustrate what Venkatesh is talking about, is alternative theories of cooperation, okay? Where instead of using a framework that sounds military, it's a framework that maybe sounds more like, I don't know, maybe hippie or some such kind of thing, okay? Where we can recast all the examples, for example, with the flower robot and or sharing parts and so on in a constructive, collaborative way. Okay. So it's just an illustration to contrast with the examples from Venkatesh, and it definitely sounds very interesting to frame the document with such kind of a philosophical frame. Yeah.
philosophy of cooperation, not of conflict.
The reason I brought it up is crypto culture basically is on the conflict end of the spectrum. So if you look at Ethereum lore in particular, there's a whole thing of like Ethereum is a dark forest. Have you seen that essay and paper? So this is the paper that led to flashbots and MEV. So if you're familiar with that whole thing, it started with this argument that Ethereum is a dark forest, like the science fiction novel. And the specific case of the argument was if there's even the smallest arbitrage opportunity in the mempool, automated bots watching the mempool will jump in and front run the trade and steal your trading opportunity. So that was the premise for Ethereum is a dark forest, and it's now become basically part of Ethereum philosophy. And this is like you listen to Ethereum discussions at all levels. red team thinking, conflict, all that is like in the completely ingrained in everything they do. So one way to do crypto robotics might be to lean into that philosophy and say, hey, we are using this technology that's designed and shaped by this philosophy of like dark forest conflict, which means the robots that we build to use this should also have like, dark, we could call this dark forest robotics. It would be a big viral meme. It would be very funny. But to your point, Eric, I think, yeah, the other end of the spectrum is to ask, why do you need to do that? Can you actually tune the trust knob to not be this extreme dark forest situation and start with a default of trust, and then if things go wrong, maybe you can lower trust and go from cooperative to competitive. So yeah, this is another, I would say, tuning variable for crypto robotics. So maybe a good structural piece to add here is, if you want to like explore crypto robotics, yes, you have to like pick all the little protocols to include in your design and architecture, but maybe you should also pick a bunch of knob settings. Like, do you want to be on the cooperation end of the spectrum or the dark forest end? Do you want to be at the neuron level of conflict or the Politburo level of conflict, right? So there's a bunch of obvious knobs here.
I want crypto to serve as a framework which makes it easier for the robots to act nice. Not that enforces them acting nice, but that supports them acting nice. If I have to choose between these things you're giving.
But that assumes that there are like sufficient resources for everybody, right? There is
No,
no
no,
competition.
no. I'm not assuming that. Obviously, you can stress the system and it's going to break. Okay? But in my house, the Roomba and the flower bot, they both have as much electricity as they want. Okay? So it's not a live or die situation, it's just convenience. The Roomba wants to work while the dog went out for a walk, and so does the flower bot. And it moves faster. So it always makes a mess after the Roomba cleaned up.
But the situation changes on the surface of Moon or Mars, right? So there is definitely a constraint on what can be done
Yes,
and
but I'm
who wants
saying
to do it.
there's obviously a conflict here, but it's not a dark forest where you keep quiet or you get eaten. That's what I'm trying to say. And therefore, what I'm looking from crypto, you know what? 5% nasty enforcement, but 95% a framework that helps the robots cooperate. Makes it easy for them to cooperate. A lot of people don't cooperate because it's difficult to do.
I think the choice to do that, one constraint boundary for that is abundance versus scarcity, like Anuraj is pointing out. Like, scarce environment, it's going to be harder to create nice defaults. Abundance environment, it's easy to be nice when there's enough electricity for all robots, right? So that's
Yeah.
one dimension. But the other one, I think, is actually openness. Like, how open do you want the system to be? If you have a set of robots on Mars and maybe there's plenty of power, but you have a bunch of robots that you and your friends designed and put there, but then suddenly a new set of robots shows up from a new country that you weren't even thinking about, right? Like, and this is kind of starting to happen. Like, space exploration used to be a US and European Union thing, and suddenly now Chinese robots are showing up on the moon and on Mars. And this is actually an openness question. You can design the system to be closed and then play nice within your closed boundary, or you can design your system to be open and say, all right, I don't know whether to play nice or nasty, but I want to at least explore the possibility of nice relations with these new robots. And if not, yeah, we can switch to dark forest mode, right? But you kind of have to. So nice versus not nice strategies are downstream of how open you want the system to be and how much abundance there is in the system, I would say.
There is also an interplay with the, for example, the laws of robotics. Okay, that would constrain what can be done and not done, whatever the policy, whether dark forest or the opposite is chosen. By the way.
Yeah, so basically interaction with the robot, right? Human interaction with the robot,
Hmm.
that constrains a lot or brings in some new constraints.
Yeah, No, but you can also you can have two robots, for example, the flower and the Roomba at a mayor's house. Okay, but if there is a human in the frame of rezoning, to take the decision, there are things they won't be able to do because that could harm the human. For example, they can say, okay, I want to get parts of the other robot, but there is a human on the way. I don't know. Okay, it's not well thought. Okay. Just I can see interplay because we're talking about a philosophy to adopt a philosophical frame, okay? But inside that philosophical frame, then we will decide laws, okay? And so there is an interplay into what kind of law can be applicable depending on what kind of philosophy, okay? And if we consider a range of philosophies, then there may be a mapping to laws that are applicable in one case or not the other and stuff like that. I don't know. I think it's worth looking into. Looks
Yeah,
like to
we
have an
are
impact.
almost 15 minutes past. A good discussion. But like we can feed this stream into the notebook I have, a notebook element, then see. And maybe what changes. Maybe we can keep working on this and have a look maybe in a few weeks again, what we have.
Sure.
Now and I will try to reshape the current PR and then have a. So I have added you guys as the reviewers. If you have any more comments, you can just put it on GitHub. It's on a PR.
Thank you.
And yeah, thank you for the discussion. See you
Yeah.
next
Yeah,
week.
Thank
thanks.
you.
Next
Bye.
time.
And thank you for all the work on the paper.
Yeah.
It's mostly now. Okay, bye.
Thank you.
Good night, good day.
Bye.
Cheers.